We'll now talk a bit about storage, data storage in Orchard Core. Well, we have already played around with content items and with media files, so we'll actually do the same thing from code in multiple tutorials. And first, we'll talk about file storage, because that's a lot easier, but still quite important. And it's also important that you know which specific services are available for that. Although, just as anything else in Orchard Core, as we have already talked about, media storage or file storage in general is also extensible, and you can roll out your own implementations too. Now, data storage in Orchard can be basically divided into categories: file storage and then database-based storage. And actually, as I mentioned earlier, this can be mixed and matched, so you can store even content items, if you wish, even content items in files, but you can still query them from an SQL database. But the usual, most common setup is that you have all your content items and other textual data or content-like data and configuration in an SQL database, and you have files, well, in some kind of file storage. So first we'll talk about file storage, because, well, you know, basic stuff. We will talk about content items next. We won't talk about other options as for database storage, because, well, those are less important, very useful, but still less important than content item storage. And we have ample documentation on them anyway. So let's do some file storage. I will create a controller now, again, just for the demonstration, from where we will create files in the media folder, and then we'll also read those files in the media folder. And in the meantime, we'll also check out where those files actually are. So let's go back to our usual module, and let's add a controller. Let's call it something like file management controller, for example, since it will be, well, about file management. Yeah, and I could also use snippets here. Snippets are little pieces of code that can generate code for you. You surely have used them because Visual Studio has a lot of them built in, like the famous prop snippet. You write prop, tab, and you get a property generated. But we have several Orchard Core and also ASP.NET Core related snippets here in the Orchard Dojo library. The Orchard Dojo library is, as we have seen in the very beginning, it's a package, well, a library of various Orchard related utilities, guidelines, best practices, all kinds of goodies. And one of the utilities here are the snippets. And as you can see, we have ample snippets here. There are various snippets that help you in various aspects of Orchard development. Basically, while you are writing some Orchard Core code in your module or even in your theme, then a lot of these snippets will be helpful for you to generate pieces of common code. As you don't have to, of course, you don't have to remember and know all of these from the top of your head. You also don't need to copy paste from somewhere. But for example, when you are creating a controller, you can just quickly generate it. And the controller is the super simple example. We have a lot of Orchard Core based snippets. In the upcoming tutorials, we'll use a lot of these snippets. So now let's also use the controller one. So instead of having a class here and having to modify it into a controller, I will just use the controller snippet, and it's actually just called controller. All the Orchard Core specific snippets are prefixed with OC, but the normal ASP.NET Core ones are just normal words. So controller, tab, and now we have a controller generated here. So file management again, and as you can see, 3 differences compared to the basic class that was generated here that the snippet adds. The class is now public, it derives from controller, and the corresponding namespace is also imported. And by the way, we also get a constructor, just cherry on top. So, of course, this is just a simple example, but there are further very useful snippets for everyday tasks. Yeah, you will see them too. Yeah, and in our controller, let's also create some kind of action. And this action will manage some files, and the file I/O is asynchronous. So let's also make this method asynchronous here. So we will return task, and we'll actually return a task string, so not an action result or something. This will be a super simple example, super simple action that will just create a file and return a message that it was okay. So let's call this create file. So first let's create a file, and then in another controller we will read files. So let's see. And in this create file, well, first we need to create a file. And how do we create a file here? Which services do we have to use from Orchid for that? And of course, you can use system.io type still. Everything that works in .NET Core naturally works in Orchid Core as well. Although, if you want to store media files specifically, you have to use a service from Orchid called IMediaFileStore. So it is called IMediaFileStore. All right, let's import the namespace, and we have an issue. Not a big one, but still an issue. The issue is that we don't have a project reference or a package reference to the package that contains this IMediaFileStore interface. So we will need to add that. Let me do a bit of formatting here, as it's a bit nice and orderly. And let's add the package. And the package is called orchidcore.media.abstractions. Abstractions. And we are using the RC2 still here, so I will install RC2 again. Remember that we talked about abstraction projects and how there are commonly for the basic services and features of Orchid, there are abstraction projects which contain only or mostly interfaces, but no real implementation. And then there are implementation projects, which are sometimes modules that contain the actual implementation for those interfaces. Now here, this is the case too. The service interface is in this abstractions package. And the actual implementation is actually available in 2 modules. One module which provides the basic local file storage, and another module which provides file storage in Azure Blob Storage. And of course, you can also roll your own. And that means that although we have added a package reference here, we also need an implementation for that abstractions project. So we also kind of need to do something with that, and that something will be declaring a dependency. So we could actually also add a package reference to the media module that contains the local file storage implementation, but usually the best practice is not to do that, not to take a dependency on concrete modules. Sometimes you have to, and sometimes it doesn't matter because you don't need that level of loose coupling. But the general best approach, all other things equal, is to take a dependency just on an abstractions project. And if you absolutely need to depend on a specific implementation of that, because you think that, well, that implementation will be always necessary, I can't imagine another scenario where we would use a different implementation out of the box. Then you can also take a dependency, but not a package dependency necessarily, on that module. And that's what we'll do. So what we'll say here in the module manifest is that in the manifest file is that we want the media module be turned, or the media feature be turned on when our module is turned on. Because we need a concrete implementation for the media management services, and we want the media module to provide that. And how we'll do that is that we will add a dependencies declaration here, which is an array here. And this will be just a short array because we'll just depend on orchardcore.media. And orchardcore.media, oops, perhaps the array construction is also necessary here. And orchardcore.media is, of course, the built-in media module. We have already used that. That will be a good implementation for the media storage services, because we know how we'll use this module and we'll use it just like that. If you happen to create a module that needs to work equally well without hassle, both in Azure with blob storage and both somewhere else with local file storage, then most possibly you wouldn't do this, but rather you would instruct your users to previously turn on one media service implementation module, or provide their own, or remember recipes. And I said that you can also put recipes into your module, or you can also put recipes into your module with setups for different scenarios. You could have a setup recipe for local development or local file storage that would turn on the media module and nothing else, and your own module. And you can have a separate recipe for an Azure-based deployment that would turn on the Azure media feature, which I think also depends on the media module, so it would turn that on too. But for now, we'll do the simple thing and just declare a dependency in orchardcore.media, but just a dependency, the manifest, not a package reference. We don't need that. All right, and let's go back to the controller now, and now we should be able to import the namespace, and we can actually do that indeed. And now let's create the file. And well, we can take a quick look at the IMediaFileStore service here. There is not much. We'll need this map path to public URL method, which is, well, retrieving a publicly accessible URL for a file. We'll use that a bit later. But what's more interesting is this IMediaFileStore service here. This is where you have all the basic operations, and you see it's pretty much just file management as usual, so nothing fancy. This is an abstraction over file storage. That's why it can have a local implementation and a blob storage based implementation. And secondly, we have a separate IMediaFileStore here and an IMediaFileStore, because IMediaFileStore is just for the media folder, just for files that you want to manage from under the media module or somehow like that. IMediaFileStore is in itself is a generic, or rather a general, just to confuse it with T. IMediaFileStore is a general file management service. It actually also has implementations, and you can use these to implement abstracted file storage or use the already existing implementations built into Orchard to access other folders. So, it's good to have your code testable, and because that's and loosely coupled to other projects, or a given class just loosely coupled to other types. Hence, why we are using dependency injection. And if you are using file management, the same things apply. So if you are using system.io and file.write all text or something like that, then that won't be testable because you will have your the concrete references to concrete framework types there. While as with IMediaFileStore that you can inject, you can get an abstracted file storage that you can easily mock or stop during a test. So let's go back to our controller and let's write some file storage here. And what we'll do is that we'll use IMediaFileStore.create file from stream async, which is, well, creating a file from a stream, you may have noticed. First of all, within the path, we can just use some kind of demo.txt, so it's easy to see, and we'll need a stream. And this is an async method, so we'll also need to await it. And of course, we can only await it if we make the whole method here marked as async. All right, so now let's also create a stream. I will use this C#7, 8 notation of using, no, not a using block, but rather a using variable like that. And let's create a stream here. Let's use a simple memory stream. Nothing fancy here, just usual .NET stuff. And this memory stream we can populate from a string right away. So we pretty much want to convert a string into a stream, so we can write it into a file. And to do that, we will use the encoding class, because here we will be able to convert an UTF-8 string into a series of bytes. So we can have something like hello world again here. So at this point we have a series of bytes or an array of bytes. Rather, we initialize the memory stream with that. And now that we have the memory stream, we can actually write that stream out to a file. All right. And pretty much that's it. So let's see what happens. I will just return an OK here, so we know that something happened. And let's start the application. This abstracted file storage is a very powerful feature. All of these abstractions in Orchard serve to make your code portable between different environments, make your code flexible because underlying implementation can be swapped out, mixed and matched, and well, make your code testable, as I've already said, because during a unit or integration test, you can instead of an actual file storage, you can use a mock of sorts, so you can actually test just what you want to test, not an underlying file system. All right, and we will need to use the same pattern as everywhere in ASP.NET Core. So we'll need to go to Dojo Course.module again. Yeah, actually this one /file management /create file. So file management and create file. All right, this is promising. Now, let's also check out what actually happened. And let's open the folder of our web project, because the media folder is actually there. All right. Now, here it is. And in our web project, we still have the app data folder that we have seen previously. And still the sites folder, still one folder for each tenant. We actually have a demo tenant here as well, and the default tenant named default. And in here, we also have the media folder. And in the media folder, we have all the previously created files, the Kitty pictures, as well as the files built into the blog recipe, and our demo.txt. So, if we open that, we will see that it indeed actually contains the string we wanted to have here. So, all of this works. That's pretty nice. Let's now do the file read actually from code 2, because, well, yeah, that's the obvious next step here. So, back in the controller, I will now create another action. Again, it will use async services, so we'll actually need to make it wholly async, and let's make it return a string again. Let's name it read file. And of course, if I would put this particular code into production, that would be very unsafe. We don't want users to be able to create files without any authentication or especially authorization. That's of course not what you do. Normally this is just a super simple example. All right, and well, we'll again need to use an async service from IMediaFileStore. Oops. And we also have, well, various retrieval methods here. Well, first of all, we have a file info async. Let's check that out first. So before actually reading the content of the file, let's read some information about it. So again, we will need a path, and well, the path will be just demo.txt again. And let's see what's in this file info. So I will just hit F12, go to definition again here, and let's check out what we have. We have an IFileStore entry. And yep, pretty usual stuff. Path name, blah, 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 less interesting because we tend to already know that. But the length, the size of the file is a bit interesting, and last modified timestamp too. So let's actually display twos. All right, so we have a file info here. And let's also return the file info as the message. So the file info, actually this can be an interpolated string, because we'll add a lot of things here. And first of all, we have a size. And the size will be, well, file info dot length. And then we also have the timestamp of the last modification. So let's also display that. Also from the file info and last modified UTC. And of course, you have to care about the culture info and everything when actually displaying dates. I will just do the super simple thing, and that will be it. But we kind of have a hunch this will actually work. So before running this, I will also add the content retrieval here, so we don't have to refresh too much. So let's also retrieve the contents of the file. And again, this will be an async service. But instead of getFileInfo async, we'll use getFileStream async. And this will also need, let me go back here. This can use a file store entry, or it can also use a simple path. I will just use the simple path here, so demo.txt. And let's check out what this actually returns. This returns a stream. So we now have to do the opposite. We will have to convert a stream into a string, so we can actually display it on the UI. So let's do that. And to convert the stream into a string, we will need a stream reader. So I will save the stream to a variable here, again using the using var notation. And then I will also create a stream reader here. This can be just a simple stream reader. Feed that stream. And actually, when the stream reader is disposed, it also disposes the underlying stream, so we don't need this here. Although there are multiple schools of thought, to be sure, you can use using here, and usually iDisposable implementations will be aware that you can call dispose on them multiple times, and they should handle that gracefully. They shouldn't fail. A more defensive approach is to never dispose objects twice, because you never know whether the person who has written the implementation actually has taken care of that. But these are actually framework types, so we know that they are nicely written. And now let's create the content, or let's retrieve the content here. And the content we can retrieve from the stream reader, feed, read to, and async. That's right. And well, this is an async method, so let's await it here. All right. Let's also display the content now. We can still do it here. And just content. This starts to get a bit. This line starts to get a bit long, but no problem. So now we have the code ready here. So again, what we do is that first we retrieve the file info. The file info will contain, well, information about the file. What we are interested here in is the size of the file and the timestamp of the last modification. And then we will also retrieve the contents of the file, which is going via a stream. And you could also be a bit more defensive here as well. So file info can be null if there is no file with a corresponding name. So probably a good practice is, even though this is just a simple example, a good practice is to take care of that and do a null check here. And well, if there is no file, then let's just return a 404. All right, and oops. Oh, well. This 404 won't work here because we are not using an action result. So I will just use a string here. And we could actually set the status code to 404, but well, you know, that's not really important here. All right. So let's go back to our file management controller, and instead of create file, we'll now retrieve or go to the read file method, and let's see what happens. Okay, so the file is 12 bytes, sounds about right. There is just a hello world string there. Last modification, that sounds about right too. Now you know when this video was created, or do you? I could just change the clock, you know. And we also see the contents of the file. So pretty much that's it. Although, let's actually check it out whether we can see this file from the admin, because, well, we should be able to see it. It's the media folder. The files in the media folder are just files as usual. If you put a file into the media folder, it should just simply show up from the admin too. So that's the basics of media management from code. Of course, there is a lot more to it. You have seen that the IMediaFileStore service has a lot more methods, but if you have done one thing here, you have pretty much done all of them. You just need to learn the API, but now you know that this is the service, or these are the services, because we have seen multiple ones. These are the services to use when doing file storage. And from this, you can go anywhere.